Hello, in this video I'm going to solve the following problem for you, which is a problem on the topic of exponential equations. Determine the solutions of the following equation. 9 to the x to the fourth plus 3 to the 2x to the fourth minus 1 all over 2 to the 3x to the fourth plus 1 plus 8 times 2 to the 3 times x to the fourth equals to 0.15. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do your calculations correctly, the answers that you will get for this problem are x equals to -1 and x equals to 1. For more similar problems, the interested audience can refer to the following playlists. The link to the PDF file that you can see on display right now is in the description below the video. Okay, now let us start solving the problem. Just look at the problem. You see that I have a power here and a power here. The base here is 9, the base here is 3. Based on your previous experience, you know that I have to connect these two bases and make them the same base. Of course, you immediately know that 9 is nothing except 3 to power 2. And you see that more or less the same idea is working for the denominator as well, because here the base is 2, here of course the base is again 2, and I have a coefficient 8 here, but we also know that 8 is 2 to power 3. So first of all, I use the power rules to simplify the left-hand side of this equation as much as I can to put in a form that I can use it in a better way. So, for example, let me start doing things case by case. For example, 3 to the power of 2 to the x to the fourth minus 1 can be written as 3 to the 2 to the x fourth and then divided by 3 to the 1. Yes, what I used this formula that if I have a to m minus n, I can write it as a fraction. The numerator is a to the mth and the denominator is a to the nth. So I use the same formula. So a, here 3 is playing the role of this a, 2x to the fourth is playing the role of m, and 1 is playing the role of n. So I exactly use this formula and I wrote it in this form. Okay, but I can continue. The denominator is just simply 3 because 3 to the 1 is just 3, but in the numerator I see because of this 2 and this 3 and the relation that 3 to the 2 is 9 and I have 9 here, this will motivate me to write it in this form. I write it 3 to the 2 and then to the power of x4. Which formula did I use? I use this formula that if I have a to some product m times n, I can write it as a to the mth and then to the nth. So I use that formula. Now what I can do, I can continue. 3 to power 2 is 9, so it becomes 9 to the x to the fourth divided by 3. So the first term, I will keep it as it is, but I was able to write the second term in this form, which is somehow related to the first term, except that I have a denominator 3, and we will fix it later. Okay. For the denominator, so let me write the denominator itself. So let me write the denominator den for denominator. I can write it in this form. The first term in the denominator, I can decompose it as 2 to the 3x fourth times 2 to the power of 1. Which formula I used? Of course, I used this formula that if I have a to the m plus n, I can write it as a to the m times a to the nth. Yes? Okay, but I can continue the denominator. The second term of the denominator, I just copy and paste. So let me change my color. I can just copy and paste 8 to the power of 3x to the power of 4. But now look what happens. Here 2 to the power 1 is just 2. So it means that I have 2 times 3 to the power of, 2 times 2 to the power of 3x to the fourth, and plus 8 more, plus 8 times 2 to the power of 3x to the fourth. So you see I have 2 of these packages and I have 8 more of them. So in total I will have 10 of them. So the denominator can be simply written as 10 times 2 to the power of 3x to the fourth. Okay, so now I can rewrite the equation again. So the numerator have 2 terms. One term I didn't do anything with it, so I just copy and paste. But for the second term, I will replace this expression, so it becomes plus 9x to the fourth over 3. In the denominator, I did a little bit of simplification and I realized the whole denominator can be replaced by that expression. So this becomes 10 2 to the power of 3x to the fourth. And working in decimals is a little bit hard, so I prefer to work in with fractions. So 0.15 in fraction form is 15 over 100, but of course 15 over 100 can be simplified by 5, so it becomes 3 over 20. Okay, so now what I will do, I have a partial fraction here. I always prefer to get rid of fractions. To get rid of a fraction with denominator 3, I have to multiply everything by 3. So I rescale the numerator and denominator by 3. This 3 will be multiplied here. This 3 will be multiplied here. But when it is multiplied here, that 3 and the 3 that is going in will cancel one another. So remember what I'm going to do. So I'm multiplying the numerator and denominator by 3, so I have to multiply every term available there by 3. So let me draw a vertical line here. Okay, so the first term in the numerator becomes 3 times 9x to the power of 4. The second term becomes just simply 9x to the power of 4. And in the denominator, because I multiply the denominator by 3, 10 becomes 30 times 2 to the power of 3x to the power of 4. And on the right hand side, I will have 3 over 20. But again, look here. I have a package, 3 of them, but then I have one more of the same package. So it becomes 4 of that package, yes? So this becomes equal to 4 times 9 to the x to the fourth, and then I would write it as 30 times 2 to the power of 3 to the x to the fourth. And then because I am seeing that the exponent here is 3x to the fourth and here is x to the fourth, I want to make the exponents the same. So what I will do, I will write 2 to power 3 to the power of x to the fourth. And on the right hand side I will have just 3 over 20. Okay, so now what happens, let me do it step by step for you. So I would write it as 4 over 30. By the way, 4 over 30 can also be simplified, so let me write the simplified version. I simplified everything by 2, so it becomes 2 over 15. And then the numerator I just copy and paste. The denominator I write x to the power of x to the fourth, and it is equal to 3 over 20. What I will do now, I want to get rid of these factor on the left hand side. So I will multiply both sides by 15 over 2. The 15 over 2 that I multiply to the left will cancel that one, but then I will have a 15 over 2 here. Okay, so and the other formula that I can use is this one. If I have a to some power n divided by b to the same power, I can write it as a over b to that power. Okay, so if I do all these things, the left hand side becomes simply 9 over 8 to the power of x4. The right hand side becomes 3 over 20 multiplied by the reciprocal of 2 over 15, which is 15 over 2. Okay, and if I now continue here horizontally, the left hand side is still this, but what is the right hand side? So the right hand side I can do some simplifications, yes? So let me change my color. So 15 to 5 3 times, 20 to 5 4 times, and then that is it. So now if I multiply 3 by 3 it becomes 9, if I multiply 4 by 2 it becomes 8. Very simple now. So it becomes 9 over 8. But now look, 9 over 8 to some power which we don't know is supposed to be equal to 9 over 8 itself. So it means there is only one possibility for the exponent. The exponent should be 1. So this means that x to the power of 4, so if you don't mind, let me write here. So x to the power of 4 is 1. There are two answers, of course. What numbers are there so that when you raise them to fourth power it becomes 1? One answer is of course 1, the other answer is minus 1. So and these are the answers to this problem. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.